All right, we're going to get going. Thanks everybody for coming here, and glad to have made it in Atlanta. We're very excited about to talk about this topic. There are some really interesting developments going on in the WES marketplace, and really after 20 years to an extent where there wasn't a whole lot of progress to a degree in the WMS space, we're now seeing some real changes. So wanted to thank you for coming here. We're talking about WES, Warehouse Execution Systems, and what's really evolving into what you might call the Smart Distribution Center. That's what we're going to talk about today. So my name is Dan Gilmore. I'm Chief Marketing Officer at Softeon. We're a supply chain software company, including WMS and WES. Some of you might recognize me for the regular column I write in Supply Chain Digest every week as well. And with me is my colleague Dinesh Dongre, who's VP of Strategy at Softeon and is extremely knowledgeable in these topics, and he's going to share his expertise today. I'm going to serve more as the play-by-play man, and Dinesh will serve as the expert analyst, and together hopefully we can get through this. Again, I think this is fun times to be aware of what's happening here, because we really are seeing some dramatic changes in the warehouse software market. If you got any questions anywhere along the way, you can raise your hand and we'll be happy to take them, or obviously leave them till the end. Still some people trying to get in here, just FYI. So let's just start with this basic question. What is a warehouse execution system? I can tell you that if you go out and search the internet, you're going to find a whole bunch of different definitions. So we're going to kind of offer our thoughts on that, because there's obviously a lot of uncertainty about what that is, and depending on who you talk to, you're going to get a bit of a different answer. But I'm going to kind of, talk about how we kind of got here, okay? And how we, from my view, and I've written about this for many, many years now, the WMS should really have the smarts, okay? And then there's this other piece of software called a WCS, a warehouse control system. And the warehouse control system is what makes the rollers move on the conveyor, turns the divert, does the induction, does the merging, does all of that lower level hardware type stuff. I believe in a well-designed system, the smarts go in the WMS, and the WCS, the warehouse control system, is just an execution system. Why do I say that? Because when you start to put intelligence into the WCS, things start to get confused about what should go into what, and you wind up having to make changes in two places when the changes inevitably incurred down the road. If you let the WMS just control the smarts and the logic, you only have to make the change there. The WCS just executes what the WMS tells it to do. And I got a good buddy, my friend Mark Freilich, who's one of the pioneers in the WMS business, and you see him uttering similar kind of sentiments there in some materials that he's written. The WCMS has all the brains, WCS has the execution logic. But it didn't always stay that way, okay? Because sometimes there's some intelligence that does wind up in the WCS. How does this happen? Well, there's a number of different scenarios where that can happen. Sometimes the WMS doesn't have enough capabilities itself to do the job in an automated system, and hence there needs to be some more capabilities added to the WCS. I've seen this many, many times over the years. Sometimes it happens because the materials handling vendor, some of the big companies you see out here on the show floor today and many others, if they kind of own the customer, they want to have the WCS add more value. Okay, and so if they're really in the driver's seat with you or whoever the customer happens to be, they're going to find a way for their WCS to be more advanced in terms of capabilities, so they can be in a better position of maybe in terms of price points, certainly in terms of perceived value. And third, and this is just the reality, oftentimes in WMS and deals where there's a conveyor automation system involved, the WMS player and the WCS player kind of make their own agreement, often, to be perfectly frank with you, sort of out of sight of the customer itself about who's going to do what. And sometimes that can lead to some smarts going into the WCS, even though, as I said at the beginning, don't think that's really where it belongs. Okay, so that's kind of the traditional scenario. But now along we have, after having had WMS for many years and after having had WCS for many years, we now have a new animal, which is called this WES. And while it's been around actually for quite a while, it's really in the last few years that it's started to gain any particular prominence here. And what has happened is the proponents of WES have said there were some problems with the existing model. The WES was developed because of perceived shortcomings in the WMS software landscape, okay? So there wasn't enough visibility to what's really happening at different nodes or processing areas within the warehouse. The flow of work based on capacities and workload isn't really working out, and so you have these big peaks and valleys in the load of flow of goods onto automation systems. And this has generated this notion of waveless order picking, which you may be familiar with, which that orders should just kind of stream out onto the floor, okay? And so you now have this new paradigm where I've got three pieces of software. I've got a WMS that's now kind of relegated to only doing certain things. I've got the WCS, which is back to the execution system, and I got the WES that has all the smarts. That's how we got where we are today, okay? This is how we got there. So now it's WES, even though it's been around for a long time, it's only in the last 3-5 years it's really started to gain much prominence. And you start to see now some of the analysts taking a look. So this is some material from Gartner, or I'm sure you're familiar with. They lay out the WCS, the WES, the WMS layer. You see Gartner talks there about it's a merging hybrid between traditional WMS and WCS. Okay, builds on the real-time visibility and insight of what's happening, adds business logic to this layer, et cetera. I don't know what that really tells you. It just says there is this different kind of software that's out there that solves a different kind of problem. So we think that's not too bad, except the problem is that it sounds like it's only focused on heavily automated DCs. WES is paired with the notion of a heavily automated distribution center. And one of the insights we've had here at Softeon is that the same principles that apply for a WES with an automated system or automated distribution center applies to a manual or mid-level automation. The same kind of issues around capacities and constraints, the same sort of issues around flow of goods, the same issues around getting the right resources in the right place at the right time, the same kind of issues around understanding order and service commitments and meeting those, they apply whether those resources are a sortation system or whether it's a bunch of case pickers or whether it's a VNA, series of VNA vehicles or whatever it happens to be. It's all capacities, constraints, flow of goods, visibility, all those things apply. And that's why I think it's so exciting now, because the market for WES is opening up not just for heavily automated facilities, but for all kinds of facilities in between. And that's what's really different today than we saw in years past. So, okay, so what kind of makes up a WES? This is a bit of a mouthful, I understand that, but that's the only way to get it out because this is what it really does. Okay, it provides visibility, control, and optimization primarily of order picking and related processes, and by related processes I mean things like replenishment and slotting and dynamic slotting and other sort of processes like that. It's really an integrated picking, replenishment, slotting set of flows of goods. Okay. That includes certainly optimization of materials handling systems, okay, but then not only materials handling systems, and really doing it today in a way that's beyond what the capabilities, even of advanced WMSs like we feel like Softeon provides, others on the marketplace. It's taken that dynamic to a whole new level. Very exciting times after 20 years of kind of incremental progress. Okay, should be able to integrate with the WMS of whoever is providing that, whether that's a third-party WMS, a legacy WMS, an ERP WMS, whatever. You can put the WES on top of that and get significant benefits in terms of productivity and throughput. Okay, it should, again, as I said, work in automated, manual, and hybrid type of distribution centers. It should be one system that manages all the automation and workflows in the distribution center, right? So it's got, rather than having a series of silos of different sort of automation systems that are working independently and have to be sort of stitched together, you want one platform that's looking at the flow of all of those systems simultaneously. That's another big breakthrough in what's happened with WCS. And really, it is moving towards a breakthrough concept of what Gartner and others are calling the autonomous distribution center. How can the work and the activities in the WMS be released and executed on the floor automatically based on conditions and events that are happening in the distribution center? It's going to change the dynamic of WMS deployments forever, frankly, in terms of where we're going. Okay? So again, if you look at it, I told the story now a couple of times, I pulled out a WMS RFP from 2003. It actually happened to be Conagra Foods. I was cleaning out my office over the holiday weekend, and I grabbed that RFP, and I read through it, and I said, you know what, this looks exactly like an RFP from 2020. In 17 years, nothing has changed, okay? Well, it has changed in the sense that of the requirements that were listed in 2003, probably back then, a lot of them weren't out-of-the-box fits with the existing WMSs back then. And maybe in 2020 they're much better out-of-the-box fits, but in terms of what the WMS can frankly do or is being asked to do, it was very, very similar. This isn't, so we've had just kind of what I call incremental WMS progress over that period of time. This isn't WMS incremental progress, this is step change process. This is a dramatic increase in the ability of a distribution center to process and flow goods out the door at maximum productivity. Really, really exciting times. So this inflection point that I've been talking about, you've got WMS, you've got WES, you should be able to deploy either one independently, but you put them together and maybe we have this new animal we're calling something like a warehouse management and execution system, okay? And we think that's really for the first time, all right? But this is, why do we still need a WES? We talked about some of the difficulties with automated systems, but this again is more general across manual, automated, and non-automated systems. What are some of the challenges that we're seeing? So number one, still a lack of real-time granular visibility to exactly what's happening in terms of activities, capacities, constraints, and demand across the distribution center at however you want to define a given processing area or processing node. Still have tremendous labor planning challenges. How do I get the right people at the right place at the right time? And we would say that resources don't only mean human resources, they can also mean equipment resources, right? Because if I've only got so many VNA trucks, that is a constraint, the real constraint that's going to dictate how I can flow orders for a given period of time out to the floor. So when you think of resources, it shouldn't just be human, it should be mechanical as well. However, having said that, obviously in today's labor scenario, there's a huge focus on how do I maximize the effort of the people that I've got on the show floor, and how do I dynamically allocate them effectively. It's just taken too long to add new technologies, whether that's various kind of automations, whether that's Putwalls, whether that's mobile robots. The time between the interest and the deployment and the time to value is stretching out a long time. That adds to a lot of cost to the overall project and limits the flexibility and the speed that you can react to opportunities and changes. There's still a tremendous amount of opportunity for further optimization of the picking, packing, or picking, replenishment, and slotting process by really applying very advanced algorithms to how to minimize travel time and do those most effectively and be aware of the constraints that are existing in the warehouse right now. This difficulty meeting carrier cutoff times and customer service level agreements. I don't know about you guys, but we're seeing quite a bit of sort of minor chaos and sometimes major chaos as 4 o'clock comes and the FedEx truck is going to go of companies scrambling around trying to identify what orders have gotten on the truck, what orders have not got on the truck. How do I get those on there so I don't miss my service commitments, all that kind of stuff. Still a big issue for many companies, obviously exacerbated by the e-commerce pressures. Utilization of materials handling system that we've talked about already there, and how do we avoid these big peaks and valleys and more level load that flow of goods into the automation, which is going to increase your throughput and probably reduce costs. And then this is really one of the big insights, and we've talked to a number of companies now about this, that even with advanced WMS, how much human decision making is still required to effectively execute the work in the DC. It's go out on your own DC floor and take a look yourself. You'll find out, even if you have a really good WMS, that there's still a lot of dependency on human beings. And why that's an issue is because A, they can't possibly process effectively all the data that is available in terms of making that decision. It often leads to a lot of dwell time as these decisions are analyzed and ultimately made, and it brings often the flow of product to at least a temporary halt. So we think there's a number of opportunities here to make some rather dramatic improvements in all of these challenges that companies are seeing. And with that, I'm finally going to let my very smart colleague Dinesh here have some comments, but anything to add, Dinesh, to this landscape?
Yeah, just a couple of quick things, from contextualizing why we're saying these common distribution problems, right? If you look at today's, dynamics, if you look at the last few years, everything from e-com to omni-channel to product life cycles. If you look at apparel design, so forth, if you take the traditional Gap versus the newer, the Zaras and the others that are looking at, the product life cycle itself is very short. From concept to market, is extremely short life cycles, which means that you have to be able to respond to that really, really aggressively, and you don't have the same context like you used to historically do. So when we talk about these problems that are there manifesting today, they are manifesting because that is the business dynamics. It's not because lack of software, capabilities. It's not because business fundamentally has changed. It's because what the market is driving, what the customers are driving. If you look at the endpoints, distribution, 2-hour delivery, all of those things are being driven by market dynamics. And that in turn is manifesting in challenges from an execution perspective, where you can't have silos addressing specific challenges. And that's where, when we talk about why WES is a bit more in vogue, bit more in demand, bit more in conversation today, is primarily because that's the business dynamics. The last piece, when I talked about labor as an example, is traditionally looked at labor purely as people. But the reality is today, or at least the last 12 to 18 months, all of you know that it's extremely hard to find good people to work in, DCs or warehouses. So shortage of resources is driving a different mindset. When you look at, in the show today, the floors around, you see a lot of robotic type, vendors out there, pitching robots and other automation things. That is being driven by the fact that there is a shortage of labor. So it's a balance between still being able to meet the demand of your customers, but how do you work within the dynamics of what constraints exist in the market today?
Yeah, and I'll just add that real quick on the robots. I mean, that I think illustrates the point. If you have an X amount of mobile robots on the show on your DC floor, that is a capacity and that is a constraint, right? And so we were actually just visited DC not that long ago that has 20 robots that sometimes all 20 are deployed, sometimes only 10 are deployed, none are deployed, sometimes none are deployed depending on the level of and profile of the work today. So factoring in that robotic resource in your planning and your execution is just as important as doing that for human resources, right? Because no one's going to have enough robots all the time for everything, right? Very well said, Dinesh. So, what is the fundamental value proposition of a WES? It should enable companies to meet customer demand and service commitments at the least possible cost, least possible operating cost. And I say that, you're going to say, what are you talking about, Dan? Well, with the right view of resources, capacities, different flow paths that are alternative, and that real-time visibility, this promise actually can be achieved. Second, there's always a gap between the theoretic throughput of a given facility as a whole or a given process, a Putwall system or whatever it happens to be. How do we close that gap between the theoretic throughput and what the actual throughput is going to be? You're never going to completely close that gap, but you can get awful close. And then again, provide that single view of management and control of fulfillment across the distribution center, not in a series of silos, but in one integrated view and execution system. That's what a WES is all about. So how do you do that? Okay. Well, number one, it starts with that visibility. You should be able to define that visibility in whatever way is meaningful to you. So it could be pick modules are a process area that you want to monitor. It could be every level of a pick module. It could be every zone within every level of a pick module. Whatever is the meaningful way for you to describe different processes and activity areas in your distribution center, you should be able to define that and get real-time visibility to what is happening there, and the system should be aware of whether the capacity is okay or whether the capacity is being challenged and we now got bottleneck type conditions, okay? We think there's an opportunity to be much more direct hands-on management of all these different picking subsystems rather than having the mobile robots operate in one silo, have the Putwall operate in another silo, have the voice system or picked light system operate in another silo. It all creates inefficiencies that are hard to overcome, and what's really hard to overcome is the exception handling, okay? There's room for a lot more optimization in terms of order batch management, flow of goods to the floor, picking replenishment, some of the things I've already harked about here. WMS does a good job. We think that it's possible to take to an even higher level with the new capabilities coming with the WES. That workload balancing to smooth out the peaks and valleys in sortation especially, but any kind of automation system. How do I make that much more consistent flow of goods through that system that's going to allow you to get more out of the same equipment you've got, or if it's a new facility, you can probably reduce the size of the equipment that's required. And then this gets to that autonomous WMS I was talking about there, where you have automatic release of work and orders to the floor based on service commitments, based on shipping schedules, based on real-time condition monitoring, based on priority, based on a number of other variables that all told are going to add up to the right solution for this moment in time, okay? And then also we're doing some interesting stuff with the use of simulation to plan, replan, and allocate resources both at the beginning of the day and as the day goes on. So I'm not going to get into this in any kind of detail. This just to let you know that the way the system could be architected, the way we happen to be architecting it, is that it's uses it's built to work with any third-party WMS. As I said before, you can probably get new life or rejuvenate a facility with an aging WMS by putting a WES layer on top of it, or you can get a combined WMS and WES system together. So ours obviously works with our own system, and you'll see there's at the bottom some note with WMS. RMS, that's our resource management system, and a forecast system, and that's really essential, as we'll get into in a little bit, in the simulation activity, so you can plan out your work during the course of the day. Dinesh, do you want to talk to this at all?
No. The only thing that I'll call out is outside of the fact that you need an abstraction in order to be able to work with your current investments. That's the whole concept of saying it can work with an existing WMS, an existing context or system landscape, is primarily to be able to leverage existing investments where it works fine, or you can offset that with the newer set as opposed to complete revamp of everything else. And the last piece, of course, everybody, you're all hearing this. There's a lot of, conversations around AI, ML, so on and so forth. I mean, they're all true, and they're all lending to the same concept, is saying, can the system learn from itself? Can it learn from patterns? Can it predict behavior? And can it improve based on patterns that you see within your context? Not just a general industry context, but within your context, can you improve and lessons learned? So that's the piece that sits on top. So this conceptual thing is intended not to solve a specific problem, but it is intended to provide a paradigm or a framework that addresses what happens today versus what's likely to happen over the next, X months and years.
Okay, very good. I'm not going to go into this. There's a bunch of the components that go into a WCS, but you just see things like condition monitor and advanced scheduler. We'll get into some of those kind of things, for example. So just as a quick notion, if I've got a multi-line order going to a Putwall system, it may take me 40% longer time to pick and deliver that good to the Putwall from a mezzanine as it takes to get it from cart and flow rack, right? So this notion of a condition monitor and a scheduler, so in effect it wouldn't be exactly this, but I'll say it anyways, I'm going to release that mezzanine line, okay, 40% earlier than I am the cart and flow rack time, so that they're going to marry up at the Putwall at exactly the same time or close to exactly the same time. So these are just, there's too much detail for today, but this is just some of the specifics of the individual components that go into a WES. Okay. So now we're just going to go through. I said these are the capabilities that a new era WES can deliver. I'm just going to go through some of these real quickly. So this is just a notion. This is a real-time dashboard of what's happening in different areas of the DC. This should be able to be configured however you want it. Again, I said, do I want to look at what's happening at the PIC module as a whole? Do I want to look at it by level? Do I want to look at it by zone within level? Or whatever that happens to be, it should be configurable so that you can monitor in real time what's happening. And not only can you see it, but the system is simultaneously monitoring it to know what to do with the flow of goods, right? This is partly for management's purposes, but it's also for the system purposes, so it can know if it has to alter the flow of work to meet the conditions that are happening on the floor at any given moment in time. Okay. One of the really exciting things is the ability to kind of have a shared component library. So there's all kinds of just a laundry list of different capabilities you see here. All right. If you are just getting WES, for example, well, maybe I'd like to have cartonization logic along with my WES. Well, cartonization has been around for a long time. It's part of, in Softan's case at least, it's part of our WMS construct, right? But because of the way the system's been architected, you could take just that cartonization component, move it over with the warehouse execution system, and tailor that delivery to what is most meaningful for you. Second, another example, if you're just buying WMS and you want to have mobile robots, you could take the mobile robot manager from the WES, and you don't need all the WES stuff, but you just need that mobile robot manager and bring it over and connect it to the WMS. So you just see an example of different functionalities here and how they could be mixed and matched depending on how you want to deploy WMS or WES standalone. If you're putting WMS and WES together, then you got it all to work with.
Yeah, just one call out here is, because of the construct of how it is set up here is what enables us to be able to put this on top of any other WMS. The points of interaction, if you will, with an existing WMS to a new WES can vary based on the maturity of the WMS that you already have installed. So much earlier WMS systems may have very limited capacity or functionalities where WES can take on a lot more without having to do the upgrade. But if you have some newer generation WMS that can do a lot more than the traditional ones, the WES can be scaled back to do just what is needed. So this is the construct that allows a WES to work effectively in any kind of environment.
Okay. So we talked about that, the difficulty it takes to add a lot of these new technologies. We see scenarios where it takes, 6-9 months to implement a pick-to-light system. Just, unbelievable, frankly, to me, that it takes so long to implement some of these kind of technologies. So we've taken a different approach where we just manage it one platform that has direct connectivity to everything from voice to Putwalls to mobile robot to pick-to-light to smart carts or whatever. So they're all operating in the same context and platform. They can all see and share the same information here. And by doing this, it gets rid of the need for any other third-party software. You don't need pick-to-light software plus the WMS, or you don't need pick-to-light software plus the WES, or whatever it happens to be. And they all, again, operate in one framework. And you could, so for example, with mobile robots, who knows how that market's going to shake out? There's all kinds of vendors out there. They're good ones. We work with Locus and we work with Fetch and talking to many of the other ones as well. But who knows going to win out in that game? We thought Canvas was going to be a great mobile robot provider. Then Amazon swooped them up and took them off the marketplace, right? So you want a system that can work not just with one mobile robot provider, but multiple mobile robot providers. If you buy 5 robots from vendor A today, and you want 10 more from vendor B 3 years from now, you don't want to have invested in an interfaced approach where you don't have any flexibility there. You want one platform where different mobile robots can be working side by side from different manufacturers in the same construct, okay? That's the, part of the reason for the framework that we've developed here. Gives you tremendous flexibility. It future-proofs your operation in terms of adding capabilities, and these capabilities can be added, I'm not kidding, in weeks, not in a matter of months, okay? That's by taking this direct connectivity approach. Those are some of the issues. I'm not going to go through that. So we kind of talked about that. I think I gave the other way before. This is the way Softeon does it in terms of this direct integration. All right. Better decisions, all the operations, all the things we kind of talked about there.
And the important thing there is also there is no implementation work, if you will. So if you're going to create, a zone where you're going to use mobile carts, for example, it's functionality added on to your current context. It's not re-implementation. There's no business disruption, so forth. When we talk about adding capability, kind of plug and play, that's literally what we're talking about, is to be able to add on a Putwall, add on a smart cart, add on a robot, multiple vendors, same vendor, any of those in your current implementation context, and they're all driven by a whole bunch of rules that then enable them to work, again, along with each other.
Next we have this thing called pick route optimization, and a little bit of an eye chart here, but if you just imagine a series of definitions of all the different ways an order can be fulfilled, okay, based on the customer type, based on the channel type, based on the order type, based on what pick strategy you're using, discrete, batch, cluster, whatever it happens to be, what technologies you're going to use in terms of scanning, voice, RFID, lights, whatever else I left out of that mix there. What you want to be able to do is define all those different routes, and then when orders come down, some kind of an engine, a pick route engine, automatically executes the logic that says, okay, it's because this type of order, here's my current conditions, here's my current status I would do, and it's going to flow that out to the different types, whether that's piece pick, case pick, all flavors of piece and case pick, pallet pick, robot pick, whatever that happens to be, and do so with the notion of conditions and events being managed in real time. So if I have multiple paths for an order to get picked, so for example, if I have a case pick area where I'm picked from pallet, but if that area gets backed up and I can instead go pick full pallets and bring them to some kind of staging location and distribute them from there, right? If I have some orders that can go through a Putwall, but other orders that can go through carts, and the Putwall starts to get backed up, I can say, okay, the pick route engine is going to pull back on the amount of work that's going to the Putwalls, give more work where I've got the resources, which is in the manual cart area, and now I've solved my problem for some period of time, right? And so this kind of flexibility to dynamically release the work in a way that makes sense for what's happening right now on the floor, this is part of the essence of why you get such big productivity gains and such gains in throughput from a properly designed WES.
Yeah.
Hopefully that makes some sense.
Yeah. The key here, again, you should see from here is the fact that it is not a static definition of how you want to manage workload. Your orders coming all through the day. Your staff is working all through the day. Dynamically, can you react to that? You plan for 8 people on a shift and 3 people show up or 3 people don't show up. How do you manage that? Or 3 people leave earlier. How do you manage that? This feedback loop is defining what is the kind of criteria that you would do in an ideal state where there was no resource constraint and you had clarity in terms of what demand was going to be there. But the reality is that demand is volatile, the resource capacity is volatile. Then how do you react to that on an instant basis, a real-time basis, where you're still not impacting your SLA, where you're still doing the right thing with the right prioritization, as opposed to having somebody make those choices in, constantly, meaning you have dedicated resources always monitoring this. That's an overhead. If you look at the overall delivered cost, having individual, at least smarter resources who are planning all of this is a significant cost. If you were to take that away and have the system dynamically continue to readjust itself, but give you the option if somebody were to make the choice and pull the trigger and say, I'm going to move people from here to there, or I'm going to create a different way of picking this, or let the system automatically do whatever the comfort level is. But the point is that system is giving you the right set of information at the right time to be able to still do that in all of that volatility that you have day to day at the warehouse.
We talked about the opportunities for optimization, further optimization. Maybe this is a little bit of a detailed topic, but Dinesh, maybe just talk to this one real quick a little bit in terms of batch optimization.
So this basically is the context of saying, if I have, more so when you look at orders coming all through the day, for example, if it's a specific batch of orders that you get from an ERP, 3 times a day, you have a pool of orders that you can then say, okay, within this pool, what is my best set of things to work together, so to speak, whether you batch them, whether you cluster them, and so forth. But what happens if you're getting orders all through the day from a website, from a marketplace, from so forth, then identifying what is the right set of orders to work with at any given time when you don't have a definitive pool ahead of time is the challenge. So when we talk about smart batching, what we're talking about is being able to look at what is already on the floor, what is coming in, within that set of stuff, what is the right set of orders that you want to put together that makes most effective use of equipment and resource that you have. It's just not that. So when we talk about cutoff time, carrier cutoff time, carrier says he has a 10 o'clock pickup, but he says he's delayed, he comes at 3 o'clock. What do? Do you still continue to focus on the same orders that were to be picked up at 10, or do you have flexibility to move that later and pick up some other orders that have 11 or a 12 o'clock cutoff? So being able to orchestrate all this, but picking the right set of orders that should be part of that work set is what this order batching is all about. Now, along with this, you're also looking at not just the right pool of orders, but the right travel path. So you're having the most efficient way to go pick all of those orders, whether it is a manual, cart somebody's moving around, or is it if it's a robot, then you have flexibility saying, I can have the robot travel on its own to the other end of the zone and pick up products and come back. So you have a slightly different context of what pick path optimization is when you're looking at mechanization. But if you're looking at people walking up and down an aisle, you want it to be the most efficient path where they're not going back and forth across multiple aisles. So the strategies of what you're using and to drive optimization. So combination of orders, the travel path, and so forth, being dynamically doing that in the right way is what we talk about intelligent order batching, if that makes sense.
And we think there's significant opportunities for most companies to really improve productivity by doing that order batch optimization. And I'm going to give you another example here that I think you're going to find interesting here in terms of potential use of mobile robots. I remember how I have my slide here. Oops, let me go back the other way. Just think about this, for example, okay, and I think this will be useful just to trigger your brain a little bit. Let's say you're investing in mobile robots, and let's say you're using the software of the mobile robot vendor to do the picking, okay? So it's kind of its silo, as I've indicated before. You're going to have some value. It's going to reduce, let the robot do the travel time instead of a human being walking. But what happens if there is a shortage of inventory in a pick location? A picker goes out, and there's supposed to be 4 in the location. There's only 2. So he or she can only pick 2, it's a shortage of 2. What happens then, right? Exceptions, of course, are kind of the bane of all distribution center operations, but when you're locked into the focused software of just a robot provider, it makes it very, very difficult to react. So what are the things that instead could be done? Well, for example, if it's not just part of a silo, but part of an overall platform, that could immediately generate a cycle count, right? And so a person's going to come out, they're going to go to that location, there was 2 shorted, they're going to say, okay, yes, you're right, there was a shortage there, they're going to adjust the inventory and then call for an emergency replenishment for future orders. But I could also have a mobile robot, we call this the new task interleaving. I could know where that picker is, and we do, but through the use of a beacon system, that was shorted the 2 orders, okay? And I could have that robot have somebody replenish that robot with the inventory, and I'll have that robot meet the picker in stream, okay? And when the picker and the robot are paired together through use of the beacon system, it's going to say, take 2 from this mobile robot and put it in the orders that you had to short before. Conversely, I could have those picks from the mobile robot, and I could have the mobile robot take those missing picks to some kind of a hospital zone or packing zone to have them addressed that way. Hopefully that made at least reasonable sense, but all that can only happen if it's one integrated system that's looking at all these variables, not if you have these silos of software that aren't really talking to each other, or if they're doing so in a very just basic interface type mode. Okay? I skip past some of this here. And just to show you some of the kind of diagnostics here, so I don't know how familiar you folks are with Putwalls, but this is just, I talked about that real-time visibility to what's happening across different areas. Here's just another example of a monitoring system that's saying, okay, of course by picking of Putwalls, here's the status of different wall lanes, if you will, in terms of operators. Just a quick example. We could certainly talk about this afterwards if you're interested.
It's the one quick thing that you can, conceptualize there as well is when you look at Putwall, the ability to be dynamically enabling or disabling certain Putwall segments based on volume. You don't have to have them all distributed all the time, so you have less resources. You can have resource work on both sides of a wall, as an example, when you're resource constrained. To be able to do that on a day-to-day basis without somebody making those choices ahead of time is the power, if you really think about it, right? So we are talking about, in this scenario, you have 16 or so or 20 Putwalls with certain bins. Now, we could talk about dynamically, can I clear out bins? Do I wait for the entire Putwall to be completed and released before I release additional orders to that Putwall? Or can I do one bin at a time as and when they're completed? Can I pack them out? Can I have a person work on 2 sides of a Putwall? All of that flexibility that you need, if you think about it, that is what the WES kind of, with WMS combination, because now I'm looking at replenishment, I'm looking at slotting, I'm looking at scheduling or synchronizing from a mezzanine to a different zones to come to the Putwall. All of that, if you think about it, has to be done in real time in a manner that is most effective, where nobody is waiting for anything. And that effectively is what we're talking about here at the end of the day.
Very good. And Dinesh already mentioned, but this notion of how do I very quickly and easily add these new technologies, if you architect the WES right, this can literally be something similar to a plug-and-play type scenario, not the months and months of work and high cost that are often seen in implementing these kind of technologies in traditional WMS and WES systems. Okay. To me, what's most exciting is this notion of automatic order release. This is the truly smart warehouse. This is the autonomous warehouse. Pick your term of choice. Gartners themselves have gone back and forth a little bit. They've talked about the autonomous warehouse. Now Dwight Klapik from Gartner's writing about the smart warehouse. Pick whatever term you like. I'm not going to go through all of this, but if you just imagine a system that's looking at a dynamic set of rules in terms of resources, in terms of capacity, in terms of priority, in terms of batching opportunity, in terms of travel time minimization, in terms of time it's going to take to deliver a pick to the final processing area. Imagine all of those kind of variables are being considered, and the system, this goes beyond just waveless picking. It's a form of waveless picking, but it's beyond what is really being out there in the marketplace today in terms of waveless picking, which is just sort of flowing orders out sort of in the order you get them, frankly, to an extent. Okay, that's a bit of an overstatement, but I'll make it anyways, okay? And to look at all those things and being able to create and release work to the floor without the need for wave planners, without the need for supervisors looking at replenishment possibilities, without all of the things that so many warehouses are doing today. And it's just going to usher in a whole new era, I believe, I'm absolutely convinced of this, where the WMS just does a lot more of the work on its own without that human decision making that I talked about at the beginning of the program here. This is very different. This isn't your mother's WMS or whatever, father's WMS or whatever you want to call it. This is something very, very new and very different. I know you got something to say here.
The only, one call out here is I'm sure you guys would have heard that, today, WMSs do that too. They say, well, when you get a hot order, what do? Yeah, you have waveless picking. You could still do a discrete order pick. Where WMSs today support that, no dispute there. You get a hot order and it creates some context of waveless where you go pick that discrete. Now, flip side, you think about that you're picking in a cluster and you have 10 orders that you're picking on a cart in a cluster, you get a hot order come in. And it's in the context of that travel path of those 10 orders. Wouldn't it be wonderful if one of those orders would be replaced by the hot order. So nobody knows anything. The picker is still continuing to pick for the 10 orders, but he's now picking the hot order automatically with no involvement from anybody. That's what, when we talk about automated order release, that's what we're talking about. Why it is different from a WMS is because it's not a discrete pick now. Now, whether it's a cart, whether it's a robot, whatever the equipment, whatever the pick strategy that you have, what is the ideal way that you can continue to dispatch orders to the floor that it can be picked to meet your SLAs. And that is what the automated order release does.
And you say, how is that even possible? This is, you're not going to be able to read this, but we have a dynamic rules engine that underlines the WMS and WES, and it allows you to set all kinds of very sophisticated multi-hierarchical, multi-option route rules in terms of how you want your facility to operate. So we're happy to talk to you after the presentation here back at our booth, but really this is the fundamental key to how that kind of smarts can actually be achieved. It's through what we call a dynamic rules engine, which, as Dinesh said earlier, is supported now by artificial intelligence and machine learning as well. Very sophisticated capabilities. I'm going to skip that. And we just talked about this metered flow of, how do I smooth out the peaks and valleys? It's through this kind of, visibility. So we have one major media industry customer that's got 7 high-speed unit sorters. And I'm just giving this as an example just to illustrate the point. And the Softion system is real-time monitoring what's going on every one of those 7 sorters. And as it's automatic feeding work into the picking and we actually have a concept of a master wave and a child wave, I guess, or automation wave. That's getting some efficiencies of batch picking, but then also allowing it to real-time stream this work into these 7 sorters. So whatever one of the 7 sorters now becomes some percent available, now all of a sudden the work starts to flow to that sorter versus the other 6 that potentially could choose. So this is just an opportunity to realize the scheduler notion that I talked about before in terms of how long it's going to take work to get done and factoring that into what work is released. All that is going to go a long way towards, you're not going to completely reduce the peaks and valleys of the automation, although if you went to the facility I'm talking about here, they're largely eliminated. But you're going to get a lot closer to it than you are with traditional approaches to automation interface between WMS and automation systems. Okay. And then the other thing that's really exciting too, I talked about simulation before. Just imagine, I'm going to pass this a little bit, but just imagine taking a day's worth of work. Beginning of the day, some of the work you know, some of the work you don't know, right? You have a certain amount of orders. Maybe you get all the orders at 4 o'clock in the morning or midnight or whatever it happens to be. Rarely see that anymore. It used to be commonly the case. But maybe you get at 4 o'clock in the morning, you got 20% of the orders. And then by 9 o'clock, you got another 20% or whatever it happens to be. Well, one of the things you can do with simulation and forecasting is say, okay, so I only know 40% of the work, but what's the rest of the work for the day likely to be? Okay, well, how would I know that? Well, through a forecasting system that's going to look at historical patterns and history and all these other kind of factors and say, okay, on the last Thursday of the month or in the month of March or whatever it happens to be, the work orders over the last few years has typically looked like this, or last week or last month or whatever the right way to consider that happens to be. And we can say, all right, this is what we know. This is what we don't know, but let's forecast what we don't know. And then as the day goes on, we're going to know more and more, right? So at 4 o'clock in the morning, we're only 20%. By noon, we know 80%, or whatever that happens to be. And now we're going to run a simulation that's going to say, okay, given this is my known and planned and expected work, how do my resources and allocation line up with what it's going to take to get the job done here? So, yeah, okay. And then, all right, next, I'll go to the next slide. So go ahead. You want to? Okay. Go ahead.
No, you can go ahead. Go ahead. No, I think what basically, sorry, I didn't mean to interrupt him, but I wanted to get to this slide because it tells you what Dan is talking about, is saying at different points in time you can look at, if you're at 9 in the morning, you're predicting what is likely to happen at 12, at 3, at 6. But as you get to 12, you have more real-time information. There's actual information there. So you continue to look at, so what it's saying is by each of those different ways, you're saying you can look ahead to potential resource constraints. You can look ahead to things that are likely to be impacting your operations, and how do you readjust? This is one part is our actual simulation, but if you look at translating this to a day-to-day execution of WMS, internally that's what it is doing. And when we talk about forecasting based on the past month or past three months, so to speak, it is not purely statistical. Typical forecast models are statistical, so I'm not looking at that pattern, and that's where when we, earlier I mentioned about an AI or ML, it is doing more predictive stuff. It is learning from those patterns in terms of what is likely, as opposed to a pure statistical model of what is likely to happen the rest of the day.
So you look what's happening here, and we'll wind this down here in just a second, but time phase planning, whether that's weekly buckets or daily, whatever, common in manufacturing, right? That's how it works. Very uncommon in logistics and distribution. So you see here these time windows, 9 to 10, 10 to 11, 11 to 12, or whatever. We're actually going out through that simulation and saying, here's what's likely to occur now given the resource mix, and the red, yellow, green, blue has to do with whether you're well-resourced, not resourced, over-resourced, under-resourced. Red, of course, happens to be, and you see some of those different kind of colors there. So this is a new approach to managing DC capacities and resources that we've had before, and it is much more like a manufacturing model that's going to take into those capacities and constraint-based planning and deliver a plan that can be adjusted based on the reality of what's happening on the floor, and that is dynamic in nature, because I may have a certain profile from 9 to 10, but from 10 to 11 that could change dramatically. So that's really what we're talking about here, which is again a kind of a step change way of looking at resource planning from what we've had in the past. So we are somewhat limited in a public forum to, this isn't just theory. We're somewhat limited in a public forum here to how much we can talk about, but if you want to come by our booth, we're at 7466, just right down the way here, or follow up later. We might be able to share a little bit more about some of what we're doing. We have proof points at a number of places here, and I will just say the results of WES are rather impressive. And that's why I talk about kind of a new inflection point for the market. That's because of the kind of results we're seeing out there working with real customers. So the benefits you can imagine, big gains in productivity. We're seeing tremendous decreases in overtime levels, and better able to manage that overtime. Reduction in that supervisory overhead from more system-driven decision-making versus human decision-making. Significantly improved throughput. Quickly evaluate and deploy the kind of technologies we were talking about here today in terms of subsystems and whatnot. Meet those customer service requirements with a dramatic, and I mean dramatic, reduction in the chaos that is running around at the cutoff times at most companies that we see, improved utilization, et cetera. And again, just to make the point, if you had in your head WES only made sense for heavily automated facilities, I'm here to give you a different idea, because those proof points we have, a number of them are in more manually or lightly automated distribution centers. Some with a lot of automation, but just as many or more with light levels of automation. That's a huge change in the marketplace. And winding it down, so where is all this going? We really are entering this era of this autonomous or smart warehouse software. It's going to automate decision making. It's going to self-tune. It's going to learn what it's doing and get better at that. And it's going to take, frankly, the human element a lot that we've required to rely on for so many years here in WMS, going to significantly reduce the amount of that we need, or at very least, it's going to present the options to humans in a much faster and better way than they've had in the past. And really this notion of kind of, the same kind of notion of flow, product flow, getting rid of latency, getting rid of dwell time that's common in lean type of manufacturing environments. Again, we think we can bring a lot of that to the distribution market. And so not too much over time. There's lots of different ways to get a hold of us here. You see some of the contact information here. We all have cards, have whatever. Our booth right down the road, 7466. It's exciting times, and hopefully you'll want to learn a little bit more about that one way or the other. So with that, I'll wrap it up and see if everybody has any questions. Any questions from the audience?
Thank you for joining us. Thank you.
All right, thanks for joining us.